So without further ado, I think we have a critical mass here. I'm going to go ahead and start talking. We'll get into this. We won't waste any more time. I'm happy that everybody has showed up. Thank you all for coming. I am here with Lina, and I'm not going to try and pronounce your last name because my German isn't good enough yet for that.
Help me with your first name. I didn't ask. It's like
yeah, something
Dimitrios
like that.
Is fine.
Dimitrios is perfect. You can call
okay,
me
perfect. Okay, no,
so,
I think I'm managing it. Dimitrios.
Yep,
okay,
exactly.
Cool.
So yeah, for anybody that doesn't know, we've got Lina here with us. She was, as you can hopefully see on your screens, she was at she's got 8+ years of industry experience, and she was working at Zalando, where she has a great case study of how they were monitoring their ML stack. And one thing that she pointed out to me that I think is incredible is how that you were doing this 6 years ago, right? And we'll get into that and much more later. But I think this is one of those ones where it's like, wow, you had to be tackling these problems before there was any tools for it, before there was anything that most people, it wasn't even a blip on their radar, and you were already trying to solve these problems. So it is great to have you here, Lina. I know it was a little confusing with the links and canceling one webinar, sending people to this link and another link. So everyone that made it, thank you for coming, and thank you for actually solving the maze of how to get here. I know that you have a lot of drive and determination if you actually showed up. So without further ado, let's start talking, Lina. Can you just tell me about how you got into tech?
Probably in an unusual way via VBA Excel programming. So I've always been an entrepreneur kind of style. So I studied business, but I got hooked into programming. And from there, I went more and more technical. So I'm coming from a business side, and I picked programming on the way. I added a master in statistics kind of related courses and ML at the time, 2011. And from there went more and more into ML. And now I'm really doing a crossover of the product side, lots of the engineering and the data scientist work.
And what made you want to go into ML? What was that driving factor?
I guess having fun.
You're just loving it too much?
Yeah, it's quite entertaining. It's like Perfect. Puzzling, solving puzzles.
Great. So let's talk about monitoring, because this is what I think everyone came for. We've had 7 minutes of chit chat. Now let's get down to the nitty gritty. What is it that makes monitoring in machine learning so much different and complicated than what you have with software monitoring?
Well, the difference is that there are more moving parts. So with software, the behavior is normally quite deterministic. So you can unit test, you can integration test, you can do the system monitoring. But now the actual data that is coming in and the model itself is an integral part of the product. And there are no established best practices yet on how to make sure that these parts play well with the others. And typically, it's also very hard to just look at the response and know that everything went well. To give a counter example, if you have a simple stack that you call to write something into a database, if you don't get an exception and the database gives you back that you wrote it to the database and it's committed, then you can be sure that this was a successful call. However, if you get back something from an ML system, it's sometimes quite hard to judge if that was good, if that got worse in some way. So just getting a response is usually not enough to tell you if that was like a success, let's say. So just looking at the no exceptions and just looking at the HTTP code or the speed is just not enough to tell if your stack is working.
Yeah. So in that is, I know we've talked before about bugs and finding different bugs, and I know you wanted to share some slides, so feel free to. I think
Yeah.
I got I stopped sharing, so you should
Yeah.
feel free to share if you want. But can you
Okay.
talk to us about some of these concrete bugs that you can encounter
Yeah.
when you are monitoring ML?
Yeah. I made like a. Do you see the slides, guys?
No.
Yet?
Yeah,
Not
now we do.
now?
Yeah.
Okay, perfect. So to illustrate these bugs that can happen, to give you some more concrete examples to work with, I can tell you some of the bugs and problems I encountered in production. So, for example, we had a case where a client released bugs. For example, one case, the client started to uppercase a case-sensitive identifier. So suddenly, all the iOS users of a certain version had an all uppercase identifier, which was not illegal. So this means some of your users suddenly won't get picked up when you try to retrieve personalized features. So this is very hard to spot. No exception will be thrown. Another example was a rollout on a page where a filter that we offered, so you could send us dynamic filters, so only give me this in size so and so, for example. So a filter which was supposed to just be applied to one recommendation box, similar articles. So let's say you're coming from a homepage, you were just looking for shoes in 38, so you want your recommendations to also be in 38. So suddenly, for technical reasons, no one thought this through. So this filter was passed through to all boxes. So also the cross-sell stuff, which might be, I don't know, a T-shirt or something. So they suddenly called us with this filter setting, which is a legal filter setting. So it's not going to raise any flags, but suddenly you're going to filter out a lot of stuff from these other recommendations, and no one will be the wiser, but the thing will be, I don't know, 15% more empty. So these are typical things that can happen when the client releases a bug. So this is on the left side area. Then, of course, there are other areas where you can introduce bugs in your own code. So we had a copy and paste error where we were pointing to some models. So this was pointing to the wrong model. You release it, doesn't throw an exception, but you will have like some weird recommendations, or it will be a bit more empty because you have some filters on top. Yeah, so we had this bug actually live for 5 months, and our cross-sell recommendation was 60% empty. And I kid you not, we did not notice that. A stakeholder had to call us and ask what happened. And so these are very hard to find.
When you're talking about that, we had Fabio on about 2 months ago, and he talked about a similar situation where there was a recommender system and it didn't give it made the same recommendation for about 8 weeks straight, I think it was. And and they calculated it and they said, okay, that just lost the company over 100,000 euros.
Yeah, it's an insane amount of money, and we spend so much time working on the algorithms to improve them by a few percent, but this stuff really loses a big amount of money. Yeah, I could tell you more in this area. So there was a developer who integrated us, and these data services are really hard to sort of understand. Like, does the recommendation make sense? So he got a response. So he just integrated that, but he always got top seller spec. So we also had a case where the app had live for a month. Same case, only these top sellers, and no one noticed that. Again, same thing. So yeah, it can be tough. So let's look at some other bugs in some other areas. There are more. So we had this copy and paste bug. Then, of course, you have the area of configuration. So not all ML services have that, but some services have business rules on top of the algorithm, which are typically something like filters. So let's say you have something where the user gets recommended articles, and you maybe want to filter them for available articles, or you want to remove heavily reduced stuff like that. So in these configurations, you can have manual errors. So someone applies a configuration that's overly strict. So how do you easily detect that if there's many configurations? Or maybe a configuration is fine, but as you move into sales season, and that thing maybe like has a sale filter or something like this, and you move in and out of sales season, so some configurations can become problematic depending on the regular change that the business is expecting as an input data. So that's something that we saw happening, that some part of the data was fine for a while, and then when you move through the cycle of the business, the seasons, it can become problematic.
And there's something that we don't need to get into now, but it makes me think about how COVID could also affect that, right? The whole idea of all of a sudden, the user behaviors are completely different for something like a pandemic. And
yes,
all of
yeah.
systems.
Sudden changes, gradual changes, all of that, yes. And then the next area where something can go wrong is the model itself. So you could forget to update the model. So Google had a case in their ML rules where they forgot to refresh a table that had important data. This is a very similar thing. And just by detecting that you have a degraded model, that because the update keeps failing or you have such a stale table, this can use you a lot. Or maybe you have changes in the input data, or the input data update was corrupted or failed halfway through. The training still happened because you didn't have proper tests of the training data. And then the model gets updated. It's actually worse than yesterday's model. So how do you detect that during a rollout? Yeah.
And so now that you've got us all a little bit on edge about this, what are some best practices around this, and how do you recommend going about it? And the first question I have, I guess, is do you need a whole team for just monitoring?
I think not. You can have simple solutions for this. Some can be as part of the platform. So some definitely should be platform services, because they require more time to maintain, and some can be relatively simple, like what I will show you now. But before I get to the solution, I want to mention one more bug source, because they're also great. We had some bugs with external services. So if you rely on other services that you call, so for example, we had a metadata service that you call to get prices or to get other enrichments for your business rules, or you call another machine learning stack. This is also very common. So we had one case where we called personalized size recommendations, and our colleagues had problems. They were giving us unknown for all the users. But we had this rule that we would filter out all the articles that didn't match the recommended size. So if a service suddenly has a lot less coverage because they released the bug, or another case where you switch your external service from one metadata store to the other, and the other one is not filled in certain fields. Or another example, we had a field that was not mandatory and it was pretty filled, but over time there was a drift in the data, and at some point it went below crucial level of fill rate, and when you filter on that, at some point your service actually starts to return worse and worse things. So yeah. So now I'm finished. Now we can get to the solution, but I really wanted to make sure that I give practical examples of things that actually happen in production.
Yeah, and I think it might be worth noting, what is Zalando? Because I'm not sure if everyone knows. They're a huge company, right?
Yeah, they're huge. It's one of Europe's biggest fashion retailers. So I think 5 billion of revenue euros, 17 countries. So it's huge. Yeah.
That was billion with a B.
Yeah.
Yeah, that's pretty big.
Yeah, it's really big. It's really big. And I was, as you can see from the example, but this applies to basically any service, but I was at the recommendations team. So we had, I don't know, I think 40 business cases for email, on-site app, and low latency, huge load. Yeah. High number of requests per second. Yeah.
Perfect. So now can you get into how you go about fixing these bugs?
Yeah. So I was thinking how we could detect these kinds of issues, and I thought we should redefine the formula that we have for a successful request. So typically we say it has to be fast, and it has to be no exception or no error. And I propose that we have something more oriented on the purpose of the ML stack. So in our case, if we have a personalized recommendation, instead of just saying it has to be fast and it has to be no error, we can add something like it has to have at least 4 articles and they have to be from a personalized algorithm. So basically you pick something that is somewhat indicative of what your service is supposed to do if it works well. And it's something like a quality metric. It doesn't have to capture like the true quality, because like who can tell if that was a good record or not. It just has to be something that probably will go down if there is a problem. So like all these examples I had here, all of these usually lead to less recommendations, or less recommendations from the first possible algorithm, the personalized one. So for example, when you look at the user cannot be picked up because of the changed identifier, the example I gave earlier, when it was all uppercase, then we will have less recommendations on average that are personalized. So basically you pick a quality metric that you just put on top of your typical SLO, and and then you can monitor that in real time for each business case. And the cool thing about this is, maybe let's talk about some alternatives. So I thought about what we should measure exactly. So what you can see here is the boundary where I decided to measure. So I decided to measure right before we return. And there are some alternatives when I had to develop a way of monitoring for us that I did not pick. And just to make you understand why this is a good boundary to measure at, here are the alternatives. So some people said, why don't you in real time measure your user actions? Like, for example, how do people click on a recommendation, or whatever your business case is like? How do people positively interact with your thing? And the problem here is that these user behaviors are super noisy. They have tracking issues. They're really hard to integrate. And if you drop by 10% at the point where you return, this is very hard to pick up without an A/B test over a while on the click rate of a user, which is very low and sort of a bit noisy. So by measuring at the point where you return, you get really, really good detection capability, because that rate, whatever you measure there, is not fluctuating as much. And you can map it very easily to all your backend data. So you have, for example, during deployment, you have information like what stack was that, so you can compare 2 stacks. It's not something you can do on front-end events.
And so, sorry if I'm getting you a little off track, but was there a lot that you did that eventually you scrapped and you said, that's never going to work? And what were those things, if you could tell us?
I was looking. So first of all, there was nothing. So in the beginning, we started looking at some more manual stuff, as you start out, or maybe automated checks that you regularly run. But I pretty soon realized we need something in real time that is integrating with the normal monitoring infrastructure. So you can actually know when something starts happening, and that integrates completely with the rest of the stuff we had. So to answer your question, not too much. Some offline checks, but this kind of stuff that is in real time, that's the way to go.
And that leads into this question that we have here from Jan in the chat. He's asking, what about tooling for measuring data drift, data quality? I guess Amazon provides DQ, I think.
Yeah.
And which could be interesting when you use the AWS stack? Was that something that
Yeah,
you had looked at, or
yeah, yeah.
it was
It's
before your
actually a
time?
friend of mine I went to school with who contributed to this.
Oh, wow.
Yeah, and I talked to him about this recently. They also had a lot of problems pushing this as a service, right? So there was even in Amazon not a lot of awareness. It's only recently that this became integrated in the stack. It existed before, but more like as a project from him and his team. So no, this didn't exist at the time, and it's also more geared towards the offline part. So that's a library for those of you who don't know, which compares data expectations that you can, I think now even infer. I'm not sure if that's already released. You can infer on your data set, and then you compare the new incoming stuff. And in Amazon, they use it to automatically check data in their data lake and create tickets. So if the team created some bad data, it has to be checked. But that thing here is actually live. So you want some checks that in real time are applied.
Perfect.
Yeah.
So then, yeah.
But just to add, maybe you should do both. So the part for DQ or great expectations or TensorFlow data validation, that is, I don't know if you see my cursor, that's to the right here on the data. So when you extract the data before you start training, you should run stuff like that. But that's not what I was trying to capture here. So you definitely need both.
Yeah, and are there any other tools that since then you have looked at and you thought, wow, those are interesting, or has it been just you made your own and you thought, okay, this is what we're going with?
I looked at a few, but I didn't create lately any stacks where I tried them out. It's still pretty fresh. So the tools I'm looking at are mostly here. So around the model. So most of the tools try to monitor the model output and compare it against some expectations. And there are also some tools for, I mentioned TensorFlow data validation. Most of the tools are for the offline part. So there are some in the online area, but they still only mostly wrap around the model. So the bugs that happen when you afterwards call another service or when afterwards you apply configuration rules, those will not be captured. So it's useful to do, but again, like this right before you return decision still seems like a good idea to me, still even now.
And so if I'm understanding this correctly, you're trying to find one metric that you can monitor that would show you if any of these are going haywire.
Exactly.
And
Which seems like a really ambitious
yeah.
idea, but it turns out it was doable.
And do you feel like that's something that could be replicated with others, or is that something very use case specific?
No, I think can be replicated with others. So if you have very different stacks, you might need a KPI per stack, but that's still, I mean, you know how many application metrics we have in our stacks, right? That's nothing. And this kind of quality-oriented one that is right before you return is just very useful because it captures all these big impact things that really degrade your quality and are like super hard to detect otherwise. Yeah.
Okay. And one thing, I mean, you've kind of gone into this, but I wanted to ask it about because a few months ago we had Shubi Jain on, and he was talking about how at SurveyMonkey they were doing their monitoring, right?
Mm-hmm.
And he was saying that they monitor three pieces. The main three pieces for them are it was the model monitoring, the data monitoring, and then the system infrastructure monitoring.
Yeah.
And when we spoke before, you said you had a bit of a different spin on that. Can you tell us about that?
I might have oversold it to you. I think I mostly agree with him. It depends a little bit how you call it, but that's, just naming. In this case, you can slice it a bit differently. So you definitely want to monitor your input and training data. That's one of the main sources for bugs. I mentioned the tools already, TensorFlow data validation, great expectations, DQ, this kind of stuff. Then, of course, you have the system monitoring and you have the model monitoring. And I kind of add this, this definition if maybe he means the same thing with response monitoring. So at the border here where you return, you have the response monitoring, and I found that quite helpful. And maybe one surprising nugget I also found is quite useful. I added some A/B test monitoring to our monitoring suite, because we were optimizing and learning on a certain set of data. So our training data was from a batch job. Then the inference data, where you have to also monitor the distribution, was from yet another system on the live path. And the success monitoring, so basically A/B testing, in our case it was Google Analytics, was yet another data source. And I found out that the evaluation data source, so the Google Analytics data source, was structurally different from our learning data. So this is another gap that is rarely talked about. So not the online-offline gap. This is the gap between, let's say you have not a substantial gap between training and serving, but the gap between serving and measuring is there. So some payment options were hard to track, for example. Then there was a bug in tracking where the express checkout was not properly covered, and I found that 20% of the orders were missing. So it could be that you're doing actually perfectly and you're doing everything right, but in your A/B test, it looks like you're not doing so well. Because this data source that no one ever looks at for quality, the analytics data, is just supposed, yeah, it's noisy, it's bots, whatever. But everyone looks at this as like, oh my God, you're never doing an uplift. You're doing the 6th iteration on this algorithm. What are you doing? What are your scientists doing? So I actually added some monitoring that measures the difference between our learning and serving data and our measuring data.
That's a perfect insight for everyone to realize. And that's something that I was going to ask you before too, with this training data. Is it replica of the actual data, and how, if so, how did that look? But I think you explained that really well on what it is. Now, moving on, is there anything else you wanted to mention to us from the bugs?
Maybe about the implementation. I'm not sure all of you are clear how this is done exactly. This is basically just a metric, just a typical application metric. I'm not sure what all of your background are, but it's pretty normal when you have application development that you have counters there or rates within each application and microservice. So this quality metric, you just implement it as a simple metric, and then you have your polling system, could be Prometheus or whatever. So we had an open source tool called Zetmon. And then what you do, you just pull the metric and you calculate your quality metric and you add an alert. So let's say you looked at that you typically have at least 5 articles which are from the best algorithm that is configured. And you look at this when you release the algorithm and it looks stable at 90%. Then you say, oh, okay, if it's below 80%, let's bring up an alert. Yeah. And then we actually had quality dashboards where you could drop any use case and you could check what that looks like right now and what that looks like over time, let's say 3 days. And you could even use that for deployment. So I had some deployment monitoring where I measured 2 stacks. So this is a deployment. So you have, let's say, 40 business cases, and each of them have a quality metric. So, and when you deploy and you have no bug, then this is basically the same algorithm and it's supposed to behave the same. So what you can do is you make the difference of these 2 quality metrics, and it's like an AA test. So if everything goes well, then there should be 0 difference in quality except statistical noise. So what I did during our deployments is I calculated these metrics for both stacks, did the difference, plotted this, so everyone could look at these graphs during deployment. We did manual deployment, not automated deployment. So what you could do is if one of these graphs structurally went below 0, because when we introduced the Spark, or maybe when we switched the metadata service that was worse, then some of the lines really dropped and were structurally below 0 the whole time. And then you can roll back and you can try to figure out what the difference is.
And can you talk real fast? I see there's some questions in the chat. I'll get to those in a minute. But
Yeah.
can you talk about this idea of why you were doing manual deployments and not automatically triggering it? Was there a reason behind that?
I actually don't know why we did that.
It's too long ago.
No, I don't know if there was like a reason why we didn't go to fully automated.
Well, it's the reason I
Yeah.
ask is because
Yeah.
it's really interesting how some we had Charles Martin on here and he talked about how automating is really not what you want to go for, especially in machine learning in the beginning,
Mhm.
because you want to just make sure that it works and make sure that everything's okay. And
Okay.
when he talked about automated deployments and this automatically retriggering, it was something that for him, he said, it can stand in the way of just getting something out there. And so
Mhm.
you want to make something like so complicated when really it doesn't need to be that complicated. You just try and get it out,
Okay.
make sure that it works, and then if it works, then you can go back and complicate it all you want. So yeah, I see John saying maybe the compliance was the reason for the not automatically doing it, but
I have no idea, to be honest. Maybe we had too many bugs that we couldn't rely. I have no idea. Most of our deployments were actually pure software related, not ML related. So yeah, I can inquire with my colleagues. We deployed a few times a day, but it's not a big bother. You just let it run in the background while you program.
yeah, really interesting. So there's a question I wanted to get to real fast about this idea of how long you store this data for assuring that measuring aligns with serving.
Yeah,
Like the data sets could be gigantic, right?
different. Yeah, yeah. Okay. We didn't actually. So to do this comparison, most of our models didn't have that many updates. So I basically calculated metrics. So let's say if we expected 50% quantile having this many user actions or 95% quantile having this many user actions, I didn't store the actual feature. I just calculated application metrics for that and defined a reasonable level. So if it drops below a reasonable level, then I alert. So I don't actually store that. I didn't actually store that data.
I see. And now I see another question that's asking about. I know we were talking about you weren't using ML specific tools. Were you using just infrastructure specific tools like Datadog or New Relic or Instana, something like that?
I just used everything we had for regular software development. So we had Grafana here, we had Zedmon, other people use Prometheus. Yeah, so whatever you have. So the good news is that this plugs right into anything you already have. You need no new tools.
Okay, perfect. Now, I think we may have already answered this one. Mani's asking, can you learn from your deployments and detect anomalies so you can see what the issues or drawbacks or things that could be done to improve automated deployments? Um, does that make sense?
I mean, the issues were different every time, every
Uh-huh.
time. But yeah, in general, I guess yes. If you look why you had to roll back, there are some nice SRE metrics like uh, how many automated deployments, what's the share of rollbacks, to determine the health of the company. How often they deploy and how many times you have rollbacks. I guess that's normal software development. For ML stuff, it was literally a different thing every single time.
To make it interesting, right?
To make it interesting, yeah. So the bugs that I told you, they're all very specific and something you wouldn't necessarily come up with. That's why it's hard to measure. You want to capture as many of the problems upstream, of course. We're always having this discussion in monitoring. Should you monitor on the symptom of the user, so a lot downstream, or should you monitor a lot of upstream and then you don't know how bad is this, how urgently should I fix this? So like a good mix is always nice. So for example, definitely measure your input training data. If it has completely different distributions and has some really weird properties or not enough lines, definitely there's a problem. And this is basically symptom-based monitoring at the very end. So it captures many of these cases which have like manifold solutions from the examples that I gave you.
Yeah, that's insightful. And that makes total sense. You have to keep a nice balance because otherwise, like you said, you're going to be on one extreme or the other and you don't realize.
Yeah.
I wanted to ask how long on average, I know each use case was different when you're finding these different bugs, but how long on average were you taking to find them?
Yeah. So actually this also how long, so it was a lot slower than normal software development because you have no logs normally. So you have to ask around, did one upstream team deploy? You have to look at some data. It's basically like archaeological work. It usually took a few hours to find out what the difference was. Unless it's very clear, like in this case, when we switched the metadata store and it happened during deployment, then you know what was different. You just made a change. There is this problem. But if it's the client, this can really take a while. Yeah.
Yeah. So I think
maybe can add to that. This is also a really open question for me. Is typically on the request path, you mostly send data that you need to get the request served. You don't send a lot of metadata. Like when the app calls you, the downstream microservice, they don't send you the app version and the version of the OS and so on. So probably I'm imagining in the future open tracing that has a lot of this information can probably combined with something what I'm doing to really get at this necessary metadata that you need to really diagnose and find out that this was the iOS app. Now I can just see the app has a problem and then I can try to reverse engineer what this is. But the callers will never send all the metadata that you maybe would like to analyze this ML specific problems, because these metadata gives you information about the data that's sent with the request.
Wow, yeah, I could see that.
Yeah.
Okay, so Gonzalo's asking, in your experience, companies should have a dedicated team to deal with model A/B testing and monitoring, or should the ML data science team be responsible for this? I kind of asked it earlier about if you need a whole team for monitoring, but this is something that we've been talking about quite a bit on here on a data scientist right now. The idea of data scientist is very broad subject, right? And a lot of people think that in the future it's going to be much more specific for each point. And so what are your thoughts around that?
So I worked in different setups. The last setup I worked on is where the team had everything under their control, a real team that owned the stacks, owned the monitoring, did the 24/7. And that for me would be included, because as soon as you split this, there's no domain knowledge of how it's used, what are these filters. It's also questionable who should look at these tasks. So we had a constant discussion in our teams. The pure engineers didn't want to look at anything data digging, and the machine learning researchers didn't want to look at this either. So this is also an unsolved issue. Who should feel responsible? But in the end, I think we're delivering a service, not just a technical solution. So we should think of this as really not just replying some response, but replying a useful response. But I guess the mindset of what belongs to running a stack that is also includes the quality of the thing is still building in most companies. If you're an engineer, you don't normally feel very responsible for, let's say, the product quality. And it's different with ML services because it's so tightly connected to the engineering.
Yeah. Yeah. And I'm wondering if you ever got into any situations where you just had like an overload of alerts, like the there was, because you set up the
Hmm.
alerts to tell you when
Yeah,
X happens, but then
yeah.
you get 25 alerts and none of them are really meaning anything.
Yeah, of course, I had to play around a little bit. So in the end, I kind of set them a bit more conservatively. So I had one catch-all alert, which is if this goes below, if any of the cases below between 30% or something like this, it's really dreadful. Someone should look at this. And then I had fine-tuned alerts for each use case where I observed the use case for a while to get a feeling where it's normally at, and then set a generous threshold that if it drops below that, probably something really is wrong. But it's a constant battle, like not too many false positive. On the other hand, you should be able to detect, actually calculated this. You can calculate here, since it's an AA test, you can actually calculate the sensitivity and the number of points you need for have that many false positives. But it's a problem because the other alerts are usually more straightforward. These are sort of um, these alerts are not fully clear. Sometimes something normal is happening, and this will create a false positive. And other alerts, like lots of warnings in the logs or a high CPU load, that's much more straightforward. There is a problem. These are here more like in some cases there's a problem, and the problem then is really bad. But in some cases, it's not a problem, and you spend a whole day just to find out that some other team is running a load test or uh, stuff like that. Yeah.
Yeah, that was my next question, is how much of your time do you feel like was spent chasing ghosts around and these false positives?
Some, but yeah. So it's I found an acceptable trade-off. And then in the end, you just distribute it over the team, because if the severity of some of the cases we caught is worth it. So it was not that this fired every day or even every week. So even if it takes a day or two to find out, if every few weeks this fires, to me, this is like more similar to incidents follow-ups. So they're just bound to happen. So I think it was okay. Obviously, I spent a lot of time to just think about this, set this up, tune this. I was the one who was driving this in our team, but I would say it's still worthwhile thing, and it's not too much from my perspective from what you gain from it, because it's really embarrassing if you don't find out. It's really harmful for the business if stuff like we were 40 or 60% empty for 5 months and no one noticed that.
Yeah, that's completely something that you don't want to be caught
No,
with. And
you're going to lose all your credibility after a while. Yeah.
yeah, exactly. So
And it's also sad, you spend months to improve the algorithm, and then something like this happens, and it's permanent. It's literally permanent until you detect it. And I kept living in fear that how many
oh
things are
no.
there? Like the things I discovered, I'm pretty confident that many companies have such things, and they just never know.
Yeah, you never realize it because it's
Yeah.
everything's giving you back systems okay.
Yeah, you just get a response, but like who knows how this is? Like the example you had, always the same recommendation.
Yeah, and I think it goes to your point of it's so hard to monitor that. How
Yeah,
can you tell unless you
yeah,
set up a system that's very well thought out like
yeah,
you've put?
yeah, yeah.
And so this system that you've basically drawn up, you
Hmm.
left Zalando and you went
Yeah,
to a new company now.
yeah,
Did you
yeah.
do the same thing there? You just recreated what you had?
We're just going live with our first proofs of concept, so let's see what I will do.
Okay.
I might test out some of these new fancy fun tools. Yeah,
Okay, very cool.
it's
Now,
a much larger scale and also less real time. So many things are more. You have a minute to respond because it's stuff that is not immediately returned to the customer, but like internal fraud stuff, scoring things. Uh, Image recognition on invoices, stuff like that, something that where there's no customer waiting for a response. So we
uh,
can have different types of quality monitoring there compared to here in a real-time use case.
yeah, and yeah, maybe that's something to talk about real fast. Just the different types of monitoring when it's, you know, these real time versus
Mm-hmm.
where you have a bit more time to monitor it.
Yeah. Yeah. So in these. Yeah, obviously you could do stuff that is more latency critical. I'm not sure if. Yeah, I'm not sure I have a very solid opinion on this. Let me work on this a while, and then maybe I get back to you.
Yeah, no, and sorry for putting you on the spot
No
with that
worries.
one, but
I
that's
just have to
something.
think it through a bit. Yeah.
Yeah, because it is a very different type of monitoring, I would think. I mean,
Yeah.
there's still the basis that's
Yeah.
there, there's the
Yeah.
foundation, but you have more time, you have a bit more leeway if it's
Yeah.
not in that real time. So, um, Money's asking in the chat, and I think this is something that we talked about, but it might be worth repeating. Just how can someone implement this if they wanted to? If because it's not like a pip install that you can do and
No.
then all of a sudden you're monitoring
No. No.
with this style that you've set up, but
Yeah.
can you just go over that again real fast
Okay. Yeah.
in case
Sure.
we missed?
So basically, let me go back a few slides. So basically, the idea is that you pick a quality metric. So I can't tell you which one this is. This will depend on your stack. You pick something relatively simple, a heuristic that somehow tells you more than just the speed and the rate of errors. So in my case, we had recommendations. So it could be that you were very fast, but you're returning just a random fallback. So I would call this a really bad recommendation. So in my case, I said it has to be the first. So let's say you have a cascade of algorithms and configurations that you try. In my case, it says it has to be at least 5 articles from the best configured algorithm. So this could be different algorithms in different cases. It depends on your business case. So you'd have to go through your business case, but I gave you some general guidelines. So pick a metric that is very easy and simple to understand. I don't know, the share of non-empty responses. You can start very simple. Or maybe you have, yeah, it's hard to pick up the examples. So maybe you can later send me what your stack does, and then we can come up with the examples for that. But basically, you pick something quite simple to understand. So go for something where you cannot tell intuitively if it drops by 10 points. What does that mean? So I went the share of responses that have 5 articles from the best algorithm is simple to understand. Every engineer, any data scientist, any product person can know if this goes down, it probably became worse. Then you implement this as a metric that is evaluated each time a request comes in, and the metric just accumulate in your application. So you have like counters. You just say +1 if this condition is fulfilled. And then you have typically what you have if you have multiple microservice instances deployed of your application, you have some service that pulls all these microservices. That is this graph. But maybe you just have one application. In this case, you don't actually need that. You can calculate it on the one instance that's serving your model. But in our case, we had like professional scalable services. So typically there were like 19 instances. So if you have just one, it's just on the one thing. And then you just count up, okay, this was a good response. This was a poor response. I had a second KPI that said that this was definitely bad. Let's say it's empty, or if it's a fallback, you wanted something personalized, but we gave you like, I don't know, popular articles or something like this. And then you count the total, and then you just divide it. So then you had the share of these good responses. And depending what your metric is, you just normally process that you would any other application metrics. So typical things we have is request per second, things like that. So this is exactly the same. Yeah. Does that clarify it a bit? So basically application metric, whatever this is in your application.
Well, I know it clarifies it for me. That I got it the second time much more. It's great hearing it again.
Okay, sorry, I didn't do a good job explaining it then on the first
No, it was
attempt.
perfect. It's just I'm a little bit slow in my learning, so I need things
No,
repeated.
it's always the presenter, let me tell you, if I'm not bringing it across. Okay, who was the person asking the question? Did you get it now? Should I?
That was from Money.
If not, shoot me afterwards, maybe in the Slack, and then we can go and maybe brainstorm some.
Yeah. Speaking of which, if someone wants to reach out to you, you're on the MLOps community
Yeah,
Slack,
yeah.
which I will share with everyone right now in case you were not here when I put it in the Slack, or I put it in the chat earlier. And for other ways to reach out with you or reach out to
Yeah,
you?
Twitter, LinkedIn, whichever one. Like the Slack, I like the Slack the best. We can.
Yeah. Yeah, it is really nice to see that. So I have one last question. Feel free, anyone who hasn't asked, if you have some burning questions in there for Lina, now speak now or reach out to her later on Slack. I was going to say forever hold your peace, but doesn't work like that.
Hope
So
not.
you told me about when you were monitoring Google Analytics data and
Yeah,
you found structural differences. Can you go into
yeah,
that a little bit?
yeah. So the idea there was that a gap can not only be between your offline training environment and the serving environment. It's clear why this is bad, but also between the serving environment and the measuring environment. So maybe you're measured on what you're served. If your A/B testing is on exactly the serving data, so let's say you dump some logs somewhere and then you compare, then you're fine. But if you happen to rely on another data source to evaluate the quality of your model and prove that you actually deliver the value, then you might want to compare if there are any differences between this data source and your serving or training data source for the same reason. Because if you optimize a different distribution and then there are structural differences because certain payment types are not tracked and there are 10% of the users missing, or in certain countries there are problems, or in our case we had this bug that express checkout was actually not sending us proper events on the training side, and we would have never discovered that because everything looked fine. You couldn't know that this was missing. And by comparing these two, we actually found out that like a huge chunk of the data for training was missing. So that already paid off. And this way, you can always be sure that the measuring is also aligned with what the training and serving does. Yeah.
Hmm. So there's one last cool aspect that I think we could talk about, and that's deployment. And you were going to mention some things about that. I don't know if you can do it within the 4 minutes that we have left, but a little quick
Okay.
blurb.
What do you want? Yeah. Okay. I already showed you guys what you can do about the quality monitoring and deployments. You can actually run it like an AA test. That is quite useful. And yeah, that is actually the thing I wanted to to mention about the deployments. So good news, we already covered it.
Perfect. There we go. So, if anyone wants to get a hold of you, you've got the Slack. You can talk to Lina more about monitoring or anything ML. You're quite active, and it is very appreciative or very appreciated by all of us. Thank you so much for joining us today and talking to us about this monitoring. You are the first of actually, we're going to be talking about monitoring in 2 weeks again. So if anyone is really looking forward to learning more about monitoring, come back in 2 weeks. We will be chatting with Arpana, and she has a monitoring tool that she has created. So that will be an interesting way to look at what you talked about today, Lina, and I think what she's going to present. And other than that, I want to let everyone know we have a workshop on Thursday with Dask and Python, scaling the data frame with Dan Gerlank. If you all want to come, it's at this time. It's going to just be an hour and a half instead of 1 hour. And tomorrow we also have another meetup. It's the same link. Everything's the same time. And it's going to be with a fellow Berliner. Lena, I know you're in Berlin. It's with Alexi. He is going to be talking to us about this full stack data scientist and if there is such a thing or if it's just a thing that people say to sound cool. Because
Excellent.
yeah,
I also want to take the time to thank you. You're really providing like an awesome community there, and I can just encourage everyone to, yeah, join. We share articles. We have a thread where you can ask questions.
yeah, and one thing that has been really nice that I've been seeing lately is that people are sharing their own articles that they've been writing about this stuff. So really, if you're doing anything in this field, we want to know about it. We want to have that be the hub. It was something that we were talking about last week, and we want it to be a place where we can come and get our questions answered or help others that potentially have gone through the same crap that we are going through. So thank you again, Lina. This is awesome. Take care, everyone. We will see you tomorrow or the next day or maybe next week.
Yeah.